When I help users to troubleshoot their printers, usually we are having difficulties with communication because either the user is very new to 3D printer or some terminology or words that they are not familiar with. So I want to make series of videos to help everyone troubleshoot or optimize their printer settings, starting with introduction to chitubox. If this is your first time opening chitubox, it's gonna look like this. Click the settings and you will have this default choice. Click this plus button and choose your printer brand and type. I will choose Frozen Sonic Mighty 8K. And look at this machine tab. This is the resolution for your printer, and here is the build size of your printer. This tab here for the resin tab, it is not really important. This is to help you calculate the cost of your resin print volume. And here we have the resin print settings. Over here, you could choose several built-in default factory settings. Let's say I will choose aqua resin grade 8K for 50 micron. Now let us have a look at the print settings. So this is the layer height. This is the z-axis resolution or the thickness of the layer that you want. The smaller the number, the better your print details. And for the bottom layer count is how many bottom layer for the bottom exposure time. This is where your print will stick or not to the build plate, depends on how well you lever your build plate and adjust the bottom exposure calibrations. And here, exposure time. It is for the normal layer exposure. You might want to do some calibration for the exposure time because usually factory setting is not reliable due to the external factor like temperature can affect your exposure time. So usually the colder your room temperature, you need longer exposure. There are so many how to calibrate your resin exposure here on YouTube, so you might want to check them out. Transition is here. Sometimes you may or may not need it, depends on your expertise. Because this video is for beginners, I would suggest to use half the amount of the bottom layer, so I will input 3. And why the transition? Because you don't want a sudden drop of exposure from bottom to normal layer. And this could cause your normal layer may not stick properly to the bottom layer. Now, let's have a look at wait mode during printing. We have two options, resting time. We better stick to this option because there is no calculation needed. And for light of delay, you need to do some calculation for the lift distance, the speed, and the delay that you want. So let us keep it simple by use resting time. First, let's have a look at rest time before lift. This is after the layer is projected. The build plate will stay for the amount of time you input before moving up to start separate the layer from your FAP film. I usually do 0.5 seconds. And then rest time after lift. When the build plate reach the top, it will also stay for a while for the amount of time that you input because it could jerk the build plate and may cause layer shift or the print surface is not smooth, especially if your whole Z tower assembly is not very strong. If you are not insert any rest time because of the sudden change of the direction from up and then down, that could be problematic. But 0.3 seconds is enough. And then rest time after retract. This is the most important from all of the three sub-menu of waiting mode. Depends on the resin viscosity. If the resin is very thin, then you may use quite short time and vice versa. This option is for when the build plate reaches the bottom, it will stay for a while for the resin to settle before the projection start. This is to ensure no layer squishing out when projecting image and then lead to fail or rough surface. And usually I would use 1.5 seconds. Now on to lift distance and speed. I will talk more in depth in future video because there is TSMC, or in simple term dual speed for the build plate moving up. The moving speed. You could see the empty field here. So for now, let's forget about TSMC, but here's the general explanation. Bottom lift distance and lift distance. This is determine how high your build plate will travel to ensure the printed layer successfully separate from the FEP. The more object in the build plate or the bigger the object is, you need higher lift distance because that means more suction force, and you might need higher distance for successful release from FEP. But keep it at 8 is already good here. And let's have the bottom and normal lift distance in the same number. It will work just fine. And also to keep things simple. For the bottom retract distance and retract distance is pretty much the same with the lift distance. And for the lift speed here, bottom lift, this is for the bottom area, and lift speed, this is for the normal layer. Same with bottom retract speed and then the retract speed. And lift and retract speed is how fast your build plate is moving. 60 millimeters per minute is equivalent to 1 millimeter per second. So for the build plate to travel 1 millimeter distance, it takes 1 second. And as of now, let's keep the default setting. It will work just fine. And from all the settings here, some factors for how long your print time will take are the lift distance, and then the rest time, the height of the object, and also your speed. And from those four, rest time and lift distance are the biggest factor. To keep the video short, I will explain more in the future video, but you should try change the rest time and the lift distance and see how much difference do they make. Speed only have a very small difference to print time. And for the advanced tab here, this is where we play with the anti-aliasing, tolerance compensation, bottom tolerance, and print time will be for future video. And for anti-aliasing, I would usually use anti-aliasing 2, gray 0, and image blur level 2. Now look over here, we have this first button. This is to add a new profile, but you have to input everything manually. And this is to change the name of the profile. And here it is. Okay. And this is to delete any profile. This is to reset the current profile. And here you could import any set profile like this, for example. And here's my print profile. And this is to export your already set profile if you want to share the settings. And this is to export all profiles. This is what all that is available here will be exported as a single file. If you like what you are watching so far, kindly like the video and subscribe to my channel. It helps a lot for me. And if you want to support my channel directly, you could check my Patreon link in video description. There will be free monthly printable model for special tier patron. Now, let's try to insert a file. You get over here and you choose open, and then open the file that you want. Because this is a chitubox free, we only have this much option to edit the file. You could copy. You could support it first and then copy later. It is fine. And then auto layout, you could choose center, X side, or Y side. This is the option to hollow your model. Let's say you want the wall thickness to be 1.5 millimeters. You could use this tab over here to slide up and down to see how it is sliced. And then this option here to put a drain hole. You could adjust the diameter of the drain hole and also the depth. Depends on how thick your models. Let's try 5. And this is to repair your model if there's any mesh or your model is non-manifold, but I will not rely on chitubox to repair your file. Now, let's say you want to save your layout. You could choose save the project, all models, all that is available in the platform, or the selected model marked by this blue highlight. I want to choose all models, name it test 1. And when I delete them, I could choose open project again and resume. You could choose save as. This will export your model that is already pre-supported as an STL file. You could choose all models or the selected models. And this open option here, you could open the file that you want to print, or you want to check the slice file from chitubox. Now let's say I would choose all of them, go to the support. Let's say I would give them heavy support and then choose the whole platform. I don't suggest to use the support settings here. This is just an example. And then you could slice. It takes 3 hours and 17 minutes. Save and then name it taste test sphere. Now you could locate the folder file here. And this is the slice file. You could copy or send to your USB flash disk for the printer. Over here is the preview of your print settings, and you could check the slice here. Maybe you want to make sure if you have any overhang or not. Here an example for opening the slice file. This is the slice file. It might take a while to load. And this is the preview of the slice file. When you open it, you could see all the pixels here. And if you press back, your original model will be gone. And this is how it looks like. Well, I guess that is all today for this introduction video for chitubox. Stay tuned for any future tutorial video on optimize your settings with chitubox.